Okay, I have started router 3, 4, 5, and 6, and this is quite simple configuration. What I'm going to do is to show run, and here I'm going to say let's see, the configuration of the interface, the configuration of router here. And I'm going to just open Notepad, and then paste the configuration here, and I'm just going to make some simple changes to the interface configuration and stuff like that. So on router 1, the first thing that I have is the other interfaces that are connected to other routers. So router 1 has Ethernet 4 connected to router 3, so this means that interface Ethernet 4 IP address is going to be 10.10.13.1/24. Then I have Ethernet 2 connected to router 5. Then I have Ethernet 3 connected to router 6, which is going to be like this. And then I have Ethernet 5 connected to router 4. So that would be 14. Okay, so I'm going to say commit, and all of these interfaces are going to go under ospf configuration. The same thing should be done on router 2. So router 2 has Ethernet 2 connected to 3. So not this one, of course. 23.2. Okay, then I have Ethernet 3 connected to 4. Connected to 4. Ethernet 4 connected to 6. Ethernet 4 connected to 6. And then I have Ethernet 5 connected to 5. Great. Okay, so I'm going to commit the configuration, and again all of these interfaces are going to go under ospf configuration. So let's go to router 3 and do the configuration here. I'm going to log in using the default username and password, enable, configure terminal, host name is going to be R03, and the first thing is going to be the interface connected to router 1, which is Ethernet 4. So I'm going to say interface ETH4 is an IP address of 10.10.13.3/24, which means that if I just commit the configuration, I should be able to ping 10.10.13.1, which is quite possible. And also Ethernet 2 is connected to router 2, so this means that if I say interface Ethernet 2, then the IP address is going to be 23.3. Okay, and also interface loopback is going to have an IP address of 3333 secondary. Of course, /24/32. So I'm going to say commit, and also the changes are going to be like this. Router ID is going to be 3333. The network is going to be the same. So I'm going to just paste this configuration here and say commit again. This is going to create an adjacency with router 1, which I say show IP ospf neighbor. And that's going to show us that router 1 and also router 2, of course, is a neighbor because of the configuration that we have here. Okay, the rest of the routers are the same, and I'm not going to show them to you, and I'm going to just configure them while pausing the video. So now all the routers are configured with basic ospf configuration, just for area 0, of course. On router 1, if I say show IP ospf neighbor, it says that I am neighbor with 2, 3, 4, and 6. What about 5? 2, 3, 4, and 6, and I'm going to just check the configuration here, show run, and so here if I just go down the list, it says that Ethernet 5, what is the interface connected to router 5? That's Ethernet 2. So Ethernet 2 is configured with the correct IP address, and this is under OSPF. The only thing that might be a problem is configuration router 5. So if I just go to here and say do show IP interface brief, it says that Ethernet 2 is configured with the wrong IP address. So if I just say interface ET2, IP address is going to be 10.10.15.5/24. Then I'm going to commit this, then the neighborship should be created again. So here we have 2, 3, 4, 5, and 6. 5 of course was in init, and after some time it is going to be full. So what is more important is this: if I say do show IP OSPF interfaces brief, it says that we have these interfaces and some of them are in designated mode, as you can see. And if I say do show IP OSPF database, it says that I have network LSA, which is LSA type 2, which in my case, of course, this is not necessary. Why? Because almost all of the interfaces here are point-to-point. I don't have any interface connected to more than one other router. So what I'm going to do is to just eliminate this. And the reason for that is now we don't have so many links here, but after, if I had a lot of links and a lot of information here, this would be something that consumes a fair amount of memory. I don't really want to spend memory on this, and also the calculation of OSPF is going to consider this, which I'm going to remove this burden as well. So what I'm going to do is to say this: under any of the interfaces, what I'm going to do is to say IP OSPF, and then we have this network type here. So for me it is IP OSPF 1, and after that you can see that I have network type here, and I'm just going to say network, and then the type of network is going to be point-to-point. And here, of course, it says IP OSPF network is point-to-point, as you can see. So I'm going to select this one, and this is going to tier the adjacency because both sides should be the same. So if I just say commit and check this, do show IP OSPF neighbor, now you can see that 4 is not neighbor anymore because the type of neighbor on that is different. So let's do this on all of the interfaces. I'm going to say Ethernet 2, 3, 4, 5, and 1, all of them. So interface ET1 is going to have this command, not this command, this command, of course. And ET2 is going to have this, ET3, ET4, and ET5 of course is going to have such command, and I'm going to commit this. The same thing should be done on router 2. On router 2 I have Ethernet 1, 2, 3, 4, 5. So if I just go back to router 1, I can just copy the whole configuration here, go back to here and say interface ET1 and commit this. On router 3 I have Ethernet 4 and 2, so interface ET2 IP OSPF network is going to be point-to-point, and it's 4, and this is going to create the adjacency again. So if I just say show IP OSPF neighbor, now you can see that I have this adjacency with router 1, and after some time of course with router 2. was the interface is selected correctly, so I have 2 and 4. So I should have adjacency with router 2 as well, which I do. On router 4, I have Ethernet 3 and 5, so I'm going to say the same thing, E3 and IP ospf network is point to point, and Ethernet 5 is going to be the same thing, and I'm going to commit this. So that's it. On router 5 I have 2 and 5, interface EAT2, interface EAT5, and interface EAT5. Okay, so I'm going to commit the configuration and do show IP ospf neighbor is going to tell me that I am neighbor with both of these routers. Come on. Router 2 is going to take a little time, but it's eventually coming up. So what are the commands that I have? To show run interface EAT2 and EAT5. So the IP address on EAT5 is wrong. So if I just go with this, that should be 25, not 35. Okay. Now if I just check the neighborships again, I should see the adjacency right now. Okay. And on router 6, EAT3 and 4. So I'm going to say interface EAT3, IP ospf network is going to be point to point, and also EAT4 is going to have the same config, and I'm going to commit this. And now going back to router 1, I'm going to see whether this has had the effect on OSPF database. So if I say show IP OSPF database, now you can see that netlink is going to be removed at some time, of course. Let me see. I don't have any netlink now. So there is no type 2 LSA, which is not necessary at all in my case. The only thing that I have is type 1, and I guess this is type 8. And the thing is, this type of opaque LSA now carries some of the information that router LSA used to carry, and that is the information about the actual prefix and information about the actual link. So this way we are going to change the type of the network to point to point. Now what I'm going to do in the next video is I'm going to configure area 2, and we are going to see some of the very important features that router 3 as an ABR is going to have.